Our lab for uncertainty and measurement is called How Confident Are You? Now the first part has you measure and record the mass of an empty 250 milliliter beaker. So I've got my balance in my 250 milliliter beaker. Part 2 says your teacher will give you a volume of water to measure the beaker. Pour the water in the beaker, record the volume of the water using all digits you can possibly record with confidence. Estimating is allowed. So here's my water. And you need to estimate. Now for number 3. Water is unique in that its volume in milliliters is the same as its mass in grams. Based on the amount of water you have measured out, write in the table what you predict the mass of water will be in grams. For number 4, measure and record the mass of the beaker and water together. Step number 5, calculate the actual mass of the beaker. Step 6, calculate the percent error in your volume measurement. Use the formula below to help you. Show all work. So real quick, for the percent error, it equals the absolute value of the predicted value minus the actual value. The absolute value, these little bars, what they're just saying is that if this ends up being a negative number, then you just need to make it positive. That's all it's saying. All right. So just take the predicted value minus the actual value, and then divide it by the actual value. If it's negative, just make it a positive. Step 7. Record the smallest increment of measurement marked on the beaker. I'll show you the beaker one more time. For part 2, we want to measure the volume with a graduated cylinder. So for part 1, measure and record the mass of an empty 50 milliliter graduated cylinder. Go ahead and cross this out. This is going to be 100 milliliters. And down here in your data table, it will be 100 milliliters. Okay? So, we have our graduated cylinder, our balance, and that's it. Step 2, pour the water from the beaker into the graduated cylinder. Record the volume using all digits you can possibly record with confidence. Estimating is allowed. Step 3, predict the mass of the water in the graduated cylinder as you did for the beaker. So go ahead and predict. Step 4, measure and record the mass of the graduated cylinder and water together. Calculate the actual mass of water in the graduated cylinder. Step 6. Calculate the percent error in your volume measurement. Use the same formula as you used with the beaker. Show all work. Step 7. Record the smallest increment of measurement marked on the graduated cylinder. If you have not printed this out, I suggest copying this into your notes. For part 3, you are going to report your data. So you need to go to the 2 previous data tables, and you need to make sure you report this data in Schoology. Now this is going to be a Google form that will just have you dump all your data in there. You'll also then go to the discussion, and you will be able to see the responses that are posted on that discussion. So that should let you see other students' data, and I want you to see how everybody's answering. A couple of key things I want you to take away from this is that you are measuring your lab equipment with the correct amount of confidence. So you should be approximating one more digit than the increment allows. And so if the smallest increment is 0.1, then you should estimate one more digit beyond that, because you could probably guess if it's between 0.1 or 0.2. Okay? Another thing is, whenever you measure it, you should always be reading from the bottom of the meniscus, and you should also be reading eye level